Let's see a problem. Four distinguishable particles fill up the energy levels 0, epsilon to epsilon. We have to find the number of available microstates for the energy for epsilon. The number of microstates for the system having total energy for epsilon. So each individual particle can be in three energy levels 0, epsilon to epsilon. We want to find the total number of microstates possible for the system having total energy for epsilon. So we have to consider the different configurations of the system which gives total energy for epsilon. One configuration is this. Here we can see no particle in the energy level 0, all the four particles in the energy level epsilon, and the energy level 2 epsilon empty because all the four particles are in this energy level. And there is only one microstate possible for the system for this configuration. So how do we calculate it? We can use this equation. The total number of particles in the system are 4. So we have this 4 factorial. In 4 factorial ways you can arrange. And the lowest energy level has no particle. So you have this 0. This is not 1. This is 0 factorial. That is 1. And the next energy level has 4 particles. So 4 factorial. The next energy level has no particles, so 0 factorial. This is not 1, this is 0 factorial. So this way you get the total number of microstates as 1. Right. Now let's see the next configuration. In the next configuration we have, this is the configuration, 2 particles the energy level 0 and no particle in the second energy level is empty, and the remaining 2 particles in the energy level 2 epsilon. So if you calculate the total energy will be 4 epsilon. So this is a possible configuration of the system. So how do we calculate the number of microstates for this configuration? Same formula. You take 4 factorial and then you divide it by the first energy level has 2 particles. So you have this 2 factorial here. The next energy level has no particles. It is empty. So 0 factorial there. And 2 particles in the energy level 2 epsilon. So the number of microstates is given by 4 factorial over 2 factorial, 0 factorial, 2 factorial. And when you calculate it, you will get 6. So the number of microstates possible for this configuration is 6. Now let's see the third configuration possible. Here you can see there is one particle in the lowest energy level, 0 energy level, two particles in the first energy level, and one particle in the energy level 2 epsilon. So total energy is 4 epsilon. Total energy is 4 epsilon. So how do you calculate the number of microstates? We are using the same formula. Here we have this 4 factorial over 1 factorial, because there is one particle in the energy level of energy 0, two particles in the second energy level, and one particle in the energy level 2 epsilon. So when you compute this, you will get what? 12. You will be getting 12. So when you calculate this, you will be getting 12 here. So these are the three possible configurations. These are the three possible configurations for getting the total energy as what? 4 epsilon. The total energy has to be 4 epsilon. So these are the three possible configurations. And the total number of microstates, total number of ways, that is given by 1 plus 6. 1 for the first configuration, 6 for this configuration, and 12 for the third configuration. And the total number is given by 19. So your answer is false.